Not a frog.
No,
that was a toad.
Frog. It was a frog.
Okay, it was a frog. Alright, so today is the last day of February. Say goodbye to our short month of February. Which, funny thing about February, because it has a perfect 4 weeks, it creates an interesting same day, same date sort of relationship. So my question for you to ponder is, does February have the same day and date? Like today is the 28th and it's Tuesday. Would that match January or March, or does it match both? So think about that. Check your calendars if you want to play with that a little bit. So yeah, okay. So of course it's going to match itself. I'm saying, does it match the month before it or the month after?
Not the month before, but the month after it appears.
Because setting 4 perfect weeks essentially makes February not happen. Because if you look at transition of days, every month we shift however many days are left over after the 4 weeks. There's no days left over at the end of February. So there's no shift in days versus dates. So, no, whatever day/date you have in February, you'll have the same day/date. So like Tuesday the 28th, we'll have Tuesday the 28th in March. So these are the only months next to each other that do that. Because February is a perfect 4 weeks. So, like, if we had, yesterday was Monday the 27th. You'll have Monday the 27th in March. Yes, except for leap year, of course. So, we were talking about simple random sampling yesterday. Who can summarize or remind us the process for taking a simple random sample? Honestly?
So first you need to assign each subject in your population a number.
Give everybody an identifying factor. Easiest thing to use is numbers.
And then you need to use a random number generator or whatever else.
Somehow randomly generate numbers.
And pick a bunch of numbers, how many we want.
How do we determine how many we pick? What is that going to determine? Or
Your sample, how big, and you pick enough numbers to determine how big your sample is.
How big do you want your sample? So you pick that many numbers.
And then use those numbers.
And then we look at that group created by those number picks. So we need to decide, is this an example of a simple random sample? If it's not, what is it? So take a moment. You can look at A, B, C, and you can look at all 4 of these options. Take a second to determine, is it simple random sample? Or if it's not, can you name what kind of sample it is? Take a second, try that, get your brain turned on this morning. This is an odd question, but does anyone know if Ethan Dale got a permission form this morning? Is anyone like friends with him?
Check. I'll ask
Will you
him.
see him at some point tonight?
I'll see him in next
I
class.
told him to come see me this morning, but I was in a meeting that I didn't know I was going to have. So I told Goldring to just tell him they're right there. But yeah, if he needs to come talk to me. No meeting I ever would classify as what I consider fun. But it was a positive meeting with hopeful, positive, what do you want to say, output, or hopefully it will cause positive change. So when I look at making an alphabetical list of my students in my class, and then I select the first 10 of them, Dom, what type of sample is that?
Okay, so I was looking at this ideology because I didn't really think about the first one.
So what part tells us how they made their choice?
Making alphabetical list and choosing the first 10.
So the list doesn't really matter, but the select the first 10. Ah, that is convenience. If we're doing the first 10, that would be a convenience sample. So it's not random, it's not systematic. We're making it easy by just choosing the first 10. Now the only problem would be if they're not available, but since it says they're the students in your class, they're available. Like it's if you look around, it's us. That would be that group. So, Elena, if we mix all the students' names in a hat and then select 10 names while blindfolded.
That would be random.
That is simple random.
Can I call it SRS?
Sure, as long as you know that there will be situations where you want to write it out. Like if you were taking a standardized test, do not abbreviate things that they won't know what it is. So like, you have to assume that the grader of your test is an idiot. And they only know what you tell them. So if you said SRS, they wouldn't know what that means. If you say simple random sample, and that's what they're looking for in the rubric, that you use the words simple random sample, you want to make sure you write those out. Okay? So as we get closer to testing, I'll probably keep reminding us of the strategies. So Andrew, if I assign a number starting from 1 to each student in our class, and then I pick 10 of these numbers at random. So, just to clarify, what does a systematic sample need that this doesn't have?
It needs a system, so like pick the first 4 or no, like 4 every 4. Or
The interval. So it needs a system that involves an interval. This does not. This is simple random. Any questions on any 3 of those? It can only be systematic if there is a system for selecting your subjects. And that system involves like an interval choice. So now we're a researcher, researching flowers. Because if you're a researcher, you would want to research something that makes you happy. So let's determine what instance of sampling this is. So I know it says which is an instance of simple random. I don't care about their question. I want us to define what are these different types. So Nish, if you choose every 10th flower in the field starting from the 3rd. Yeah, what? So that is a systematic because we start with the 3rd and we choose every 10th. Ashley, if we choose 3 flowers from the field, do we know how we chose them?
No.
So we actually can't answer what type this is.
But what did you convenient because you're in the field?
We don't know how we chose them, though. If I choose this one here, I walk way over there, choose this one there, and I walk way over, it's not convenient. But I don't know how. So the question is, how did we choose? So we don't know. On this second one, it's not good enough. And actually, that's too small. To only choose 3 flowers, that would not be a very good sample because that is very, very small. It's hard to compare only 3 values. You choose the 50 closest flowers to you. Noah, what do you think? That is convenience. You choose 50 flowers from different locations in the field. Acadia, what do you think? So is there a system? Is there an interval for how we're choosing? No. So all I'm choosing is 50 flowers, and I know they're from different locations. So different locations is not convenient. There's no system, so it's not systematic. This is random. Now, here's the thing. It would be very difficult to assign a number to every flower. That would be very difficult. But if I blindly, so I'm not like making choice based on anything, I'm just choosing. So I walk over here and I say, whatever flower is touching my right toe, I'll pick that one. I walk over here without looking. Whatever's touching my right toe, I pick that one. Like, you got to do it randomly. But the closest that we could identify to, that one would be our random. Yeah? So the problem is we don't know where. This says from different locations. If I just bend down and I pick 3 flowers, that's convenient. But if I pick one over here, one over there, and one over there, then that could be random, but we don't know how. So this could be random, but we need to answer the how. There's not enough details here. So we could also say NEI, not enough info. So it could end up random. It could end up convenient. It actually could end up systematic. And we don't know how they chose the 3. Does that make sense? We just don't have enough information.
What was the meeting about?
The what?
The meeting that
Doesn't matter. How are systematic sampling and simple random sampling similar? How are they different? I don't know why you did this about testing. So there was an error in our testing last year. We're working very hard to make sure there's no errors in our testing this year. It was not an error that did anything bad for students, but it was just not good. So we don't test until March, April. That's why we're having meetings in February into March to make sure that we're ready. So pretty soon you guys will find out about this, but we will be asking that everyone bring it. If you have your own calculator, bring it in with you. We're going to have to check it and we're going to have to clear it. But we don't have enough calculators to give to the whole 7th grade. So if you have a calculator at home, please try to bring it into school sometime in the next month. Okay, so that it's in your locker and ready to go when we need it. Yeah.
Do we need to do the standardized testing this year? Is it required?
I mean, there's no point in you opting out. It only hurts our school. So we would prefer that you take the test. It does no negative thing to you. The only thing opting out does is saves you from taking it and gives us a score of 0 for you. So instead of it saying you didn't take the test, it gives us as a school like a 0 score for you. So we would prefer that you take the test. If you're going to try to opt out, your parents have to call Mr. Short. How are systematic and simple random sampling similar? So could my systematic sample give me a random sample? Could my random sample end up systematically? Think about these things in your head. How could they be similar? How could they be different? Jaslyn?
Both of them have the intent of being unbiased.
Okay, so what is going on now that I'm on the back page?
What?
It's just writing really low. So, unbiased. Hopefully. They're shooting to be unbiased. Am I? Or, yeah.
So, I would say random could sort of be systematic, but I don't really see that. I think they're kind of like similar because systematic. So random could end up being systematic, like if you drop a pen and it like just it's like every 3rd flower. But I don't think like systematic could be random because you have a system.
So this is where like opinion and situational outcomes gets really tricky, right? So could a random sample, when I choose numbers randomly generated, could that end up having a system behind it? Very unlikely. It could in a rare case, like I might get all multiples of 10 or something weird like that. It could in a rare case happen. Could my systematic sample that I choose be a random assortment of the population? Yeah, we would hope for that to happen. So that's kind of hard to write down. I agree with you, there could be kind of tie-overs, but it's really hard to formally decide. Jeremiah?
So what if you just so if you have a bucket of random numbers and then you just put them all down and they're not necessarily in order and you choose every 4, you could get like 4.
Systematic, your set has to be ordered. To start systematic, you have to, you just have to have them in line, whatever that order is. So the problem is, don't think about having numbers. You have subjects, you have things, golf balls, people, whatever you want to look at. That's your bucket, your population. Then you have to put them all in a line.
Yeah, that's what I meant, you think it out.
Yeah, but so don't think about them as numbers yet. Then once they're all in a line, then I number them. Then the numbers are in order. Then I either systematically choose every 5th or whatever, or I plug a random number generator to spit out what numbers I choose. It's very rare you're going to end up getting the same groups. Very, very, very rare. Actually, on the way in this morning, talking about how we're going to be getting into probability, You guys know March Madness is coming up, right?
Yeah.
So those of you who care about basketball, March Madness is coming up, which is called March Madness because people fill out brackets that are predicting who's going to win. So everyone knows the original teams that start the bracket, but then you're making predictions for every round after that. There is an offer from Warren Buffett, this very rich guy, for $1 billion, with a B, $billion, to anyone that can pick the perfect bracket. Literally predict every winning team accurately. The odds of doing that, because every selection it gets a rarer and rarer chance, because if I'm picking a team in round 3 or 4, they had to win the whole way to get there. So that's more unlikely, like as you get in towards the middle of the bracket. I'll show you guys a bracket at some point. Maybe we'll all fill out brackets. The odds of winning are 1 out of, so 1 is your numerator, out of, I don't have a guess for what number goes on the bottom, how big it would be.
1 out of 20,000.
1 out of 20,000, not rare enough yet. Needs to be rarer. 1 out of Julian? 1 out of 50,000, not rare enough yet.
That's crazy.
Monica?
1 out of 500,000.
1 out of 500,000, not rare enough yet.
1 out of
Sean?
1 out of a million.
Not rare
1 out of a
enough
billion.
yet.
Is it 1 out of a billion?
1 out of a trillion.
I think you're
I don't care. Yeah, I'm teaching. Who cares? Guys, I don't care about my cell phone. I am teaching.
Can I have it?
So,
I don't care.
Quadrillion.
It's 1 in a billion.
1 in a trillion.
1 in a quadrillion.
I say it's true.
1 in a quintillion.
here's your number.
What? 1 in 9.2. What's quintillion?
1 out of 9.2 quintillion. So guys, that's million, billion, trillion, quadrillion, quintillion. This is why he's offering $1 billion.
If someone gets
Nobody's
this,
going to win.
Someone
Now, somebody can. It's possible. But there's one possibility out of 9 quintillion possible options.
Watch everyone win, though.
Dude, like, if you understand mathematics, the odds of one person winning, they have a better likelihood of getting hit by a train, hit by a bus, and struck by lightning in the same day than winning the NCAA round. I'm serious.
That would
Like,
suck.
this
That
is
would be a
where
really bad
probability
day.
gets really fun.
Stop.
Okay, so people are total.
Dead by a coconut bowl.
Yeah. Wait, so how would Warren Buffett know that you had like a legit bracket?
I think it's only for his employees. So maybe I'll post this article. So Warren Buffett perfect bracket. There you go. So I will try to see if this. I'll try to find a reputable one of these and post it on the Schoology. But I mean, these are all pretty reputable sources. USA
1 million
Today,
for
CNBC,
life.
Forbes, and ESPN. Like, so this is legitimate. But now he's actually changed his offer to make it more reasonable. He's I'll post the article. But he's offering $1 million for the. So did you hear the same story I was listening to this morning?
No,
Who was
it just
saying
said it up there.
Oh,
Yeah,
so
it's
he's
a
offering
million
$1 million a year for life for anyone.
for every year.
I forget what it was, but he's also offering $100,000 to just whoever goes the furthest at his like whoever works for him that goes the furthest has like the best bracket. Essentially, he's got a ton of money and he's trying to give it away to people for guessing based on probability.
That's like
So,
skating.
we'll revisit March Madness. And, well, so another way that they could be, the biggest way that they're similar is they're both shooting for unbiased results. I believe. I'll post the article. I just heard it on the radio coming in this morning, which I thought that probability was really funny. 1 in 9.2 quintillion. Like, so I'll
That's
show you, there's a
insane.
probability website that shows all the different probabilities, like what's your probability of getting hit by a bus, or drowning in the bathtub, or like all these different probabilities that are pretty ridiculous. They're all more likely than winning the bracket.
Wait, what about the lottery? Like the mega.
So I was showing some people yesterday, I won the lottery.
What?
Yeah, you
How
should
much?
have.
So on the back of the Ohio lottery tickets, and if you want to see this, you can come up after class.
rich now?
I won $2. So I bought this to be able to show you guys probability. And ironically, I won, so I'm gonna have to go turn this in. So, oh my gosh, this is worth $2. On the back of the ticket, right at the very top, it literally says overall odds of winning. 1 out of, or 1 ratio with like the colon, 4.92. So, in buying a lottery ticket, you have about a 1 in 5 chance of winning with that ticket. You could just win $1 and get your money back, which then essentially nothing happened. But I'm a winner, but nothing happened. You didn't make any money. So I won $2. So yay, I doubled my money.
You want to give that $2 to me, right?
If $1 million is employees only, wouldn't that make it an even smaller chance for the perfect bracket?
No, because that's each person's. So your chance of choosing a perfect bracket is 1 out of 9.2 quintillion. Noah's chance is the same. Mona's chance is the same. But so your chance of winning the billion, if you don't work for Warren Buffett and you can't win it, then your chance is 0. But your chance of picking the perfect bracket has not changed. You know what I mean? So there's where the difference comes in.
Well, I just wanted to say that last year we did the March Madness brackets. Our whole grade did, and there was this one person that was Jacob Spades. He got like the closest, and
We did a competition last year.
Yeah, and he was like really close. I think it came down to the 4.
Final 4.
Yeah, and he had messed up one of the final 4.
And you can actually, there are ways that you can mess up a couple early choices and still end up with the right final 4. Like weird things can happen through the bracket. So like we'll talk about this. I'll get some brackets. We'll fill some out. I don't care at all about basketball. Like most pro sports, they're overpaid. They're playing a game, but the probability side of it is kind of fun.
Wait, what about this? You keep that lottery ticket and you make brackets, and then whoever wins gets the $2.
You can't cash in a lottery ticket. You have to be 18.
Well, you can do it for us.
Just tell them that
How about you win a jar of Skittles or something?
Yes.
Good job, you
Moving on.
We should do that though.
We don't live together.
I don't like Skittles.
I didn't say we won't, but we are moving on right now.
Yeah, we've been on this topic for a long time.
Yeah, because of you. What?
Because of you.
What? Don't care who did it.
Are we good?
Yep.
Because the past 30 seconds has just been Okay, this table. Ah, crap. Again, this is one where we don't have what Pearson shows. It doesn't matter. We're going to look at this table. Penguins are more fun than stars anyways. Sorry, I need to get that table. But I did not put it on the notes because the notes didn't have enough space.
Ice baby. Ice baby.
Yeah, that's what it was. Thank you. So this, got it, goes to this table down at the bottom. So, describe how we would collect a sample of 9 stars using a simple random sampling technique, then choose that simple random. So, this does not have all 50, because a table of 50 stars would not fit on your paper. It would be the whole paper. So, how could we choose 9 stars? 9 stars have already been chosen here. But how could we do it so that it would be a simple, random sample? Right?
You can close your eyes and then move them around, and then as soon as you open it,
That is not actually appropriate. So that, could possibly work. But mathematically, that is not a true, valid way to choose your sample.
well, you can be blindfolded like this. You can just have a bucket.
Okay, so yeah, the mix them up in a hat sort of thing. There is that. What's the formal process? If we were to take the formal process, do you know that, Jeremiah? Okay, so make sure you pay attention with this because it's on the front of your notes too. Ellie?
I do believe you assign each star a number, and then you randomly select a number.
So, right here, we can make this a real easy process. Order. Doesn't matter how. Just make a list. Hey guys, it looks like somebody passed gas. Let's just be aware of it. You need to be writing down your notes. I don't care if your nose is in turmoil right now. We order our data. We then number it. We then random choose it. That's it. Order, number, random choose. So, so the thing with order is you can't just have a pile of things, right? I need to put them out so I can see each of them, give them each a number, and then be able to work with that. So we did that, quote unquote, and we got our table of 9 of the 50 brightest stars that is down here at the bottom of the page. Apparently I did something to that. Now I'm mad at me. So now we'll come back to those stars. Actually, let's go straight to the stars. Forget it, since we're already talking about it. So we chose 50. Based on this sample, how many would we infer or predict are between these magnitudes of 0.5 and 1? So how many would we infer from the table would, in the group of 50, actually be between that magnitude? So remember how we made those predictions, or how we made those inferences. You kill the process. In a way, you can kill the process and then start the process over again. I might break something here, so stay tuned.
I thought you deleted it or something.
I kind of am. I'm deleting it from what's running on the computer right now.
Watch you break the whole.
I'll reopen it. So what am I going to use from this table? How do I make this inference? I've got my 9 stars that I chose. These are real stars, real names. Whoever discovers it gets to name it. Monica, how do I make that prediction?
Can you predict it? Because it seems like you can just count the number of stars.
Okay, so we can. We can first see how many are in there. So this one, is that it? So we get 2. But we're trying to predict out of the 50. So out of the 50, how many do we think? Yeah, so we use our 9 to predict out of our 50. You know how?
So here now we have a ratio of 2 between the 0.50 and 1 out of 9, and we can that's a fraction. And now we need to find how many stars out of 100.
So we take our probability from the sample. So that's the probability from the sample. And then times the population. So we take our probability that we saw from the sample, multiply it by your probability, or your population. We will get 100 over 9. So our prediction here then, sorry, what did you get? Well, what was the something? Would you write it up or down? Okay, so 100 divided by 9. If it was 90 divided by 9, that would be 10. We have 10 left over, so we get 11 and 1/9. Just remember, whatever's over 9, that number repeats. So this would be 11.1 forever. So we would just round to, we would guess that 11 of our 50 stars would be within that magnitude. Have you guys heard about the solar system that they discovered that has 7 Earth-sized planets?
Yeah, they said 7 planets. They said 7. Yeah.
That are all Earth-sized and could all have water.
Yeah.
Pretty crazy.
I saw it on Snapchat.
How? So I want to show this at Take a Risk, hopefully during forum,
They
because I want
announced
to show it
it
to everybody. How they detected these planets is amazing. Because, and well, we should do this other prediction. But what they did was they pointed their Yeah, but the thing that detects light, so not just telescope, but like it's a computer that's detecting amounts of light. So they pointed that, and they had the computer track how much light is getting to us from that star. As the planet would pass between the star and the telescope, or the observer, that would dip the light, right? Because if I pass something between a light bulb and you, it dips the light. Every time that happened, it marked it. The computer marked that point. And as they followed that data over time, they saw that there were distinct dips that happened systematically throughout time. So that system let them tell the speed of orbit, and how much the light dipped let them know the size of planets. They then were able to figure out that there were 7 distinct cycles of light dipping. Some happen more often because they're closer in. Some happen more rarely because they're the planets further out. Either way, all they did was have a computer program make a graph of this. All of a sudden, they discovered 7 new planets that are Earth-sized that might have life on them. The people that discovered the star, so they named the star based off the telescope that discovered it. I'll show you guys the article. Yeah.
So, what are the planets that they found, like, what they used to look like? Because, like, light takes over.
They're not that far away,
possible it could
actually.
be
They're only a couple light years away. I forget how far.
Like 40
No, they're actually pretty close. Like, well, I forget how far the system is away from us, but the planets to each other are also very close. So it would take us a very, very long time to get to Mars. We're talking like months, years. In this solar system, it would take days to get planet to planet. Like, the planet-to-planet travel would be very quick. So the thing that immediately makes my brain think, you guys can pack up, we're like out of time. But that immediately, wait, no, we're not online. No, sorry, the next period will be out of time. The thing that immediately makes you think about is, are there beings traveling from planet to planet? Or are they at least communicating? Because if they're that close, you can send communications that way.
You said that the planets are closer to us than
No, so that solar system, the planets in that system are closer to each other than we are to Mars. Our solar system is fairly spread out because we're not that close to our other planets, actually. It would take us a long time to get there. They're far away. We got to do this at least. Go ahead.
How long is a light year?
How far light travels in a year. You can look it up. I forget exactly what it is. It's the distance that light can travel in a year. You can look it up. I forget. Dude, it's not measured in years. It's measured in distance. So, you turn on a light now, point it in a direction. However far it made it in a year would be a light year. Light travels at a constant rate. So, if we can finish this problem, I'll pull up that other article. So I can tell we're interested. I like when you guys get passionate. So let's make a prediction. Based off what we see here, we want to predict how many of these penguins would weigh between 30 and 40 pounds if the whole population is 35. So we use our sample data to find our probability. So Whitney, how do I set up that probability ratio? What is it that I'm looking for specifically? We want penguins that are
in between 30 and 40 pounds.
So let's find, well, this guy's in between 30 and 40, this guy's in between 30 and 40, that guy and that guy. Oh, Oscar, you're a penguin. So we get 4. What goes on the bottom? Guys? 7, because there are 7 in this sample size. We then make our prediction by setting up that 4 sevenths times 35. This works out really nicely. 35. Go ahead and say it.
Okay, so 35 divided by 7 is 5.
So these can cross cancel. This can become 1, that can become 5, and we get 4 times 5. So our prediction will be 20 penguins. So, our prediction is that there would be 20 penguins between that week. So, we should continue. So here's my question. Can we agree that tomorrow we will move quickly, stay on task, and get through 14, 6, and 7?
Yes.
Because we would like to take the 14 test on Friday. So we get it done. Guys, you're in the accelerated 7 class. We gotta keep moving. So, that said, we have a couple minutes left. Actually, for a second.